Yeah, am I audible?
Yes, ma'am.
Hello?
Yes, ma'am.
Am I audible? Is my
Yes,
screen
ma'am.
visible? Is my screen visible? Hello?
Yes, ma'am. Your
Hello?
screen is
Yeah.
visible.
Okay, okay.
Yes,
Yeah.
ma'am. You are audible.
Good morning to all. So, yeah, many thanks, Sweta, for inviting me in this FDP. So, today I would like to talk about my research on multimodal information processing and its application in NLP. Okay, so I am Dr. Sriparna Saha, currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. And as a part of our research, we are also developing some tools and data sets, and those are available in my site, in my website www.iitp.ac.in /slash resources.html. So yeah, you can download those resources from my web page. So let me now. So these are currently my research areas. Like we are working on conversational AI, like chat, developing some chatbot. So with there are some industrial project like given by Accenture. So Accenture is interested in developing some chatbot, and the chatbot which can sell a product. Like suppose there is a there is a virtual shop, and the customer is visiting that virtual shop. Customer is specifying the product specification, and now the customer wants to purchase the product. So if the product is not available, then basically that the chatbot can persuade and also negotiate on with the customer. So this chatbot is having the human-like intelligence. So the chatbot is having persuasion and the negotiation capabilities. So then we are also developing some chatbot in the healthcare domain. Like for example, we are developing some motivational chatbot. So motivational chatbot means suppose some person is they suffering from some mental disorder like depression or anxiety or the bipolar disorder. Then the chatbot is generating some empathetic and motivational utterances. So this way we are working heavily on the conversational AI field. Then we are given a project by Ministry of Home Affairs, where our task was to detect the that whether the meme contains hate speech or not. So given a meme which is posted in the online platform, whether the meme contains hateful content or not. And you know that meme can be written in Hindi, English, code mix language, or in many other languages like Thai or Malay languages. And we developed the data set also. Like when we started doing research in this particular field, there was no data set available in the Hindi, English code mix language. And Indian people are multilingual and they speak multiple languages. So often when we are writing in social media platform, we switch between languages, and this is called the code mixing or the code switching. And that so identifying the meme, identifying the hate speech from the code mix language is a very difficult task, and we detected the hate speech from the code mixed memes. Then another task is the intervention generation. Like that given a meme, suppose someone was posting some hateful content in the internet. So can we detect whether can we prevent that person from spreading the hateful meme? So maybe we can generate some warning messages, that why that message should not be spread. So this is called the intervention generation. And also, like, we should not only identify that given a meme that is hateful and non-hateful, like we should also explain the decision of the machine learning system. Like if the machine learning algorithm is saying that a meme is hateful or non-hateful, what are the reasons behind this decision? So the explainability is also a part of that. And that for a meme, for detecting this hate content, sentiment and emotion and sarcasm are very very important. Like if the person is very much sarcastically writing the meme or the person is writing in a sentiment and emotional way, then that maybe we can easily understand that there is a hateful content. Then another task is the complaint mining. Suppose the person is writing we are purchasing product from the online platform like Amazon and the Flipkart, and then the person is writing the reviews in the online portal, and this we can collect, and then we can detect whether there is a complaint or not, and if there is a complaint, on which aspect of the product the person is complaining. So this is we have digged into deep, and we worked on complaint mining, and also we have worked on summarization systems. I will discuss in detail regarding the summarization systems. And we have collaborations with many industries like Sony, Samsung, Accenture, Crisil, Elsevier, Adobe, and also Microsoft. So yeah, these are some of the research areas that my team is currently working at IIT Patna. So now let me discuss about the main theme of my talk today. What is multimodality? So multimodality is a recent research areas. So which is basically mimicking our real world experience. In our real world also, whenever we have to take a decision about an object, we used to use multiple sensors. Like we used to collect information using multiple sensors. Like we are having multiple sensors. Like we can see the object, we can touch the object, we can feel the object, we can smell the object. So we can collect the information using multiple sensors, and then we can take a decision about the object. So that this is called the multimodal learning. Similarly, in many areas nowadays, like for example in social media, whenever we are posting something in social media, this is only not only the text we are posting, but we are also uploading some images or videos about the event in online, in news channels also. There are e-version of the news channels, newspapers, and in the e-version of the newspapers, whenever the reporters are writing about the news, they're also uploading the images. They are uploading the videos of the events. So that way everything is multimodal. So that it is a combination of text plus images plus videos. So that is the basically it is basically multimodality, that we are not only processing the text data, but we are processing text plus image plus audio plus video data. So another important thing is that that why multimodality is important, because that text plus and image are complementary to each other. Some concepts can be better described using text, like some abstract concept like independence or the freedom, gravity. So these concepts can be better described using text. But how a piano looks like, or that how a pangolin looks like, that is better described using image. So basically that text and image provide us complementary information. So another important thing is that that in NLP there are many tasks. For example, in the left hand side you can see a task of emotion recognition. So when we have to detect the emotional state of a speaker, suppose two speakers are speaking, and we have to detect the emotional state of a speaker. So we are not only seeing what the speaker is saying, but we are also seeing the speaker's audio tone, or the facial expression, or the or the body movement. Okay, so after seeing the facial expression or the audio tone and the etc., we can easily detect the emotional state of the speaker. So only the utterance is not important, but the audio tone and the facial expression, eye movements are also giving us clues to detect the emotional state of the speaker. Like if the audio tone is high, then maybe the speaker is angry, and if the audio tone is low, then the speaker is sad. So audio tone plays a very important role. Similarly, facial expression and also the eye movements will also provide us enough information. On the right hand side you can see some tweets. So there are images and the text. So that text and the image we have collected from the tweets, from the Twitter platform, and we are classifying these tweets into two categories: informative and non-informative. and you know that then we are basically categorizing them into informative and non-informative categories, especially during a disaster situation. Physical connectivity is lost, but people stay connected with each other through social media platform. So they used to post regarding their updates in the social media, whether they are safe or what is the current situation in the nearby locality. They used to post in the social media platform. So we can download the images from the social media platform, and then we can categorize those posts into two categories: relevant and non-relevant. And all the relevant posts can then be summarized, and the summary can be given to the rescue team, and the rescue team can plan for the rescue operation. So, there are many applications of multimodal information processing. Like, my students are applying these multiple sources of information, and they are applying them for various application areas, like dialogue systems, like when the person is providing the information to the chatbot, that time the person can also upload the image. Like, for example, the person is providing the specifications, so the person can also write the specifications in text, or the person can write the specifications in image. So the specifications can be given either in text or image form. So, like, for example, dialogue act classification, like, if we need to understand what is the type of the dialogue, whether the person is giving a command, or the person is giving a statement, or it is a question, or it is a like, what is it, is a open question, or it is a greeting, we it is a agreement, or it is a disagreement. So better if we can also understand, consider the audio tone or the facial expression, then maybe we can get a better understanding. So similarly, in case of tweet tag classification, we are not only considering the tweet plus the emojis, because emojis are also giving us better information, whether it is a threat related message, or whether it is a sad message, or it is a happy message. So the emojis play a very major role in giving us the appropriate impression of the tweet type. So, and as I mentioned that when suppose we are developing the chatbot, and user is giving a specification, so user can specify the specification either in text or through images. So then we are also working on the complaint mining. So when person is writing the complaint, like suppose I am not happy with the quality of the product. So that I can type, I can upload the reviews in the online platform, and these reviews can contain the textual reviews, as well as we can also upload the damaged product. So that maybe the images we can also upload, or sometimes the videos of the damaged product can also we can upload in the Amazon site or in the Flipkart site. So this way complaint mining is also multimodal, because here we are having the textual modality, image modality, plus video modality. So we are considering all the three modalities, and then we are detecting whether a particular post contains complaint or not. Then cyberbullying detection, I told you that given a meme, we are detecting whether this is it has a cyberbullying or not. So, and also we are not only, it is a binary classification that it contains hate and non-hate, but also we are determining the explanations, like which part of the image contains hateful content, okay, or which part of the text contains hateful content. So we are also detecting the explanations. And then intervention generation, like suppose someone is posting some memes, so why we should also ask the person not to post the meme, okay. So intervention means providing some warning messages. Then summarization, when we also worked on multimodal summarization, like in the input side we can have the text, image, and the videos. In the output also we can have a text summary, image summary, and the video summary. And nowadays we are working on the comment aware summarization, where suppose there is a news, and there are many readers who are reading the news, and they are providing the many comments on the news, okay. So readers are sometimes correcting the news reporter because news reporter was biased while writing the report, or news reporter was has done some mistake while writing the report. So maybe that the readers have corrected the the news reporter. So we should also consider those those comments into account while writing the summary. So we are working on readers comment our summarization. Then rumor detection, there are many rumors, and these rumors also contain image plus text. So we developed some data set in the Indian context for the humor detection, because there was no Indian data set in the humor detection. Then medical question answering. So sometimes nowadays, before going to a doctor, we often write our medical concern in many medical blogs or forums. So these medical questions are very long. So can we generate a summary of these medical questions? So this is called the medical question summarization. Okay, so we are writing our concerns in the medical blogs, and we need to generate a summary of these medical questions. And then there is a recommendation system, like suppose that we are working with Sony with on the recommendation system. Like when we are providing suppose we are watching some films in the Netflix or the Amazon Prime. That Netflix used to remember our choices. Like if we have seen some romantic movies, then Netflix will always provide our new recommendations for the romantic movies. So that but they in the, mostly the recommendation systems are only genre specific. So basically we are now working on the multimodal recommendation systems, like based on the movies trailers. From the movies trailers we can extract some audio video features, and using this audio video features we can develop some multimodal recommendation systems. So let me introduce, the task of summarization, and I will showcase you how can we solve the multimodal summarization problem. Okay, so summarization is a very important task in natural language processing. So summarization means that you have a long document and you need to summarize this. Like there is a lengthy document and you have to summarize this into concise summaries by preserving the essence and the core message. Like you have a long document and maybe you are not able to understand this document, so you need to get a summary out of this document. So you have to get the essence and the core message from this long document. There are two types of summarization techniques. One is called the extractive, another is called the abstractive. So extractive means that you only select few important sentences from the document, and that will be your summary. So it is very similar to selecting some important sentences from the document, and that will generate the summary. And the abstractive means that you have to read the entire document and then you have to write in your own words. Okay, so this is called the abstractive summarization. So here you have to read the entire document and then you have to generate the summary in your own words. So these are the two types of summarization techniques. So there are many applications of summarization. So one is, as I already mentioned, during the emergency briefings, like there is a disaster situation and people are posting in the online platforms. So we can download all these online posts, and then we can categorize them into relevant and non-relevant. And all the relevant posts can be summarized, and this summary can be given to the rescue team, and the rescue team can plan for the rescue operation. Then legal documents are also very lengthy. You know that lawyers or paralegals and the legal professionals often deal with lengthy legal documents, including contracts, court opinions, and the case briefs. So they are often dealing with this long they are often they find difficulty in reading these long legal documents. So we need to summarize the long legal documents. Then third is the educational content. So educational contents are also very lengthy. So students maybe find very difficult in reading the entire chapter. So maybe they need some summary of the chapter. So sometimes you need to apply the summarization on the entire on summarization of the entire document, educational content. So what is going on in the summarization field and how the summarization has evolved? So one is that in today's digital age, professionals face the challenge of processing vast amounts of information. So initially people were working on only single document summarization, but nowadays researchers are working on multi-document summarization. Like they are working on, like suppose you are searching with the word Taj Mahal. So Taj Mahal, the information about Taj Mahal is available in multiple documents. So now, how can we consider multiple documents and then generate a summary? So this is called the multi-document summarization. Then I will be discussing about this multimodal summarization. Like when you are searching with Taj Mahal, maybe you got some images of Taj Mahal, you got multiple documents on Taj Mahal, and also you got some video documentary on Taj Mahal. So now, given some videos, given some images, and given some documents on Taj Mahal, how to generate a multimodal summary? Like you need to have a text summary, you should have a image summary, and you should have a video summary. Then maybe there are some documents on Taj Mahal, and there are many readers who are reading the document and they are providing their comments on Taj Mahal. So can we incorporate this reader's comment while generating the summary? Okay. So basically, you know that is called the reader's comment aware summary generation. So we have a summary and there are many readers' comments. So can we incorporate the reader's comment into account while generating the summary? Now the thing is that all the documents or all the reader's comments are not useful. So we need to check the authenticity and the credibility also. So all the readers' comments are not useful. So we have to categorize the readers' comments into three categories. Some are neutral, some are irrelevant, some are complementary. Like maybe readers have given some information, and now in the readers' comments there are some additional information. So then these readers' comments are complementary to the document, and then some comments are supplementary because some comments contain some information which are not present in the some comments contain some information which are already present in the document. So we have to categorize the comments into three categories: supplementary, complementary, and also irrelevant. Then nowadays, large language models are in hand. So can we incorporate the leverage, the advantage of large language model in generating the summary? So that is another challenge. And obviously, you know that another thing is this multilingual capabilities. So many maybe documents are available in multiple languages. So some documents are available in Hindi, some are available in Bengali, some are available in Marathi, some are available in Punjabi. So how can we integrate this multiple documents while generating the summary? So let me introduce this text, image, video summarization task. So here we are having a multiple set of text documents, multiple set of images, and multiple set of videos. And then we are applying a summarization technique, and we will be getting a text summary, images as the image summary, and also a video summary. Okay. So in the output, we are having a text summary, some images as the image summary, and also a video summary. So this is our text, image, video summarization task. So for the data set, there was a data set by this Zhu et al. So this Zhu et al. In 2017, they proposed this data set where there are 25 topics, and each topic is having 20 text documents per topic, 3 to 9 images per topic, 3 to 8 videos per topic, and each topic was having 3 reference summaries, okay, goal summaries annotated by the human annotators. But this data set in the input side there was multimodality, but in the output side it was only text summary. There was no multimodality in the output side. So what we have done is that first of all we employed some human annotators, and then we made this data set multimodal. So in the output also we we basically generated some image summary and also some video summary, okay. So in the output also we generated some image summary and also some video summary. So that was this paper, text image video summary generation using joint integer linear programming. In our this ECIR paper we released this data set. We made this data set multimodal, like this data set was no, it was multimodal in the input side, but in the output side it was only textual summary. So we manually made this multimodal. So then we proposed a joint integer linear programming based framework. So what we did is that we extracted all the unique sentences from the documents, and from the videos we extracted the speech, and from the speech we extracted all the sentences, and sentences are added to the text set, and from the email from the videos we extracted the keyframes, and the keyframes are added with the images. So this way we are having two sets, image set and the text set. And now there is a integer linear programming where our variables, for each sentence there is a variable, for each image there is a variable, okay. So now you know that we are clustering the basically there is a adjacency matrix, okay. So we are basically, our task is to cluster the set of sentences in the semantic way. So like say if the sentences are semantically similar, then we group them into the same cluster, okay. And similarly if the images are similar in the vector space, then we group them into the same cluster. So by integer linear programming our objective is to cluster the sentences into the same in the same cluster if they are semantically similar, and also we have to group the images in the same cluster if they are semantically similar. And our objective functions are that the saliency in the image, like the compactness of the clusters, text cluster should be high, and also the compactness of the image cluster should be high, and the text cluster centers, the separation should be as much as high, like compactness should be low, and also separation should be high in the text clusters, and the compactness of the image cluster should be low, and the separation should be high in the for the image clusters. And also text cluster centers and the image cluster center should be similar to each other. So these are the three objective functions, and we basically combine them by a weighted function, and that we optimize by using integer linear programming. And finally we get a text summary, and also we get some text clusters, and from each text cluster we selected the cluster center, and that cluster center is the sentence, that cluster center is selected in the text summary. Like we form the text text clusters, and each text cluster is having a text cluster center, and that text cluster centers form the text summary. Similarly there are many image clusters, so from each image cluster we selected the centers, and that form the image cluster image summary. And then there is a post processing step, like we select that particular video which is very similar to the text summary and the image summary, and that video is added in the video summary. So this way our final summary is formed. So we have a text summary, some images as the image summary, and also one video as the video summary. Now in the second in the second approach, what we have done is that we now form the clusters, the text clusters and the image clusters, by using the multi-objective optimization based framework. So I hope I am audible, no? Like there is no problem with my connection.
Yes, ma'am, you're audible.
Okay, okay, yeah. Thank you. Yeah, because this online, no, that it's not possible to understand, no? Yeah, so basically in the second approach, we followed the similar approach only, but now the clusters are formed using multi-objective optimization, because you know multi-objective optimization gives us the freedom to simultaneously optimize multiple cluster objective functions. So basically here the first part is very similar, like we from the videos we extracted the speech transcripts, and from the speech transcripts there are many sentences which are added to the text set, and also we have extracted the key frames which are added to the image set. So this way you have a text set and also image set. Then we projected them in a common space. We have the text vectors and the image vectors, and then we applied the non-dominator sorting genetic algorithm 2, so NSGA2. So our population or each chromosome is having a set of text cluster centers and then a set of image cluster centers. And then you know that this image text cluster centers and the image cluster centers are evolved by crossover and the mutation operations, and we optimized simultaneously three objective functions. So these are the steps of the non-dominator sorting genetic algorithm 2. So in each chromosome, we have a set of text cluster centers and a set of image cluster centers, and we apply the crossover and the mutation operations. So we generate the new chromosome P dash, and then we merge P and P dash, and then we again select the top P solutions. So these there are many there is iteration, and finally we select the top P solutions. So after the n number of generations, we select the top P solutions. So you know that these are the results. So you can see that. So basically, we get we are able to we are able to outperform all the existing techniques. So our results, ruse is a measure of basically ruse is a measure of summarization. So ruse measures basically is a it is a string matching. Like you have the actual summary, and and your model is generating a summary. So now you can do a string matching. So how many words are longest subsequent match. So how many consecutive words are matching in your goal summary and your generated summary. So that is the longest subsequent match. So that is basically the Russell. So we are measuring the Russell score, and also the image recall and the image precision, image average recall and the image average recall. We have calculated, and the video accuracy in 44% cases our model is able to correctly detect the video. So then we proposed two concept, supplementary visual enhancement and the complementary visual enhancement. So what happens is that you know that given the original text summary, so text summary is our original summary, main summary. Now we consider that image summary as our auxiliary modality. So you know that what happens is that this adjacent modality either can provide some complementary information or can provide some supplementary information. So let me introduce this concept. So like if your text summary is the Russian airliner which crashed in the Sinai desert, killing 224 people, was down by a bomb. Analysis of the black box recorders indicates the plane had been carrying 217 passengers, including 17 children and 7 crew members. Families of the passengers have gathered at St. Petersburg airport as bodies begin to arrive back in Russia. So if this is our text summary, now you see in the left hand side there are two images. So in the left hand side images, they convey the same information which are present in the central text summary. Okay, so that's why these two images are saying the supplementary enhancement, because here images convey the same information which are present in the text summary, And if you see the right hand side in images, these two images convey the information. Relatives of the victims created the memorial at the St. Petersburg airport. ICC is claiming responsibility for the crash, with both Russia and Egypt deny it. So here images convey some information which do not have any, like, which are here images have information which are not present in the text summary. So basically you can see that these two images are called the complementary enhancement. So basically so this is the idea that given the central text summary, you know that sometimes images are supplementary enhancement or the images could be complementary enhancement. So basically we defined, that one quality estimator function that given the original text summary, whether a particular modality has really has some quality or not. So basically that was the idea that this quality estimator function takes as input an entity to be evaluated for enhancement subject to a central modality based summary, and gives a quality score ranging from 0 to 1 based on relevance to the text summary, 0 being no relevance and 1 being highly relevant. And the diversity takes as input an entity to be evaluated for enhancement to a central modality based summary, and gives a diversity score ranging from 0 to 1. So diversity means that it provides whether the other modality is different from the central modality or it is providing the same information. So if it is giving 0, that means that it is providing similar information. If it is giving 1, that means it is providing the very diverse information. Okay, so basically if the diversity is less than some threshold, then this is called the supplementary enhancement. If the diversity is greater than some threshold, then this is called the complementary enhancement. So you know that this is the our proposed model. So the similar approach only, but now it is a two-stage approach. In the first stage, we are applying global coverage text format. So a clustering-based approach where we are applying the clustering on the text vectors and the image vectors together. So we are applying the clustering on the text vectors and the image vectors together, and then there is a visual enhancement engine in which we are categorizing the images into supplementary and the complementary type. Okay, so if the image is very very similar to the text summary, then it is called the complementary supplementary. And if the image is different from the text summary, then this is called the complementary. So we are in each solution we are putting some supplementary images and also some complementary images. This way we are enhancing the summary. And then there is a post-processing step. In the post-processing step, we are also adding a video summary into the solution. So this is our proposed model. So first we are clustering the text and the image vectors, and then we are categorizing the images into supplementary and the complementary, and then we are adding some video into the into each summary. So this was about that Sigaya 2021 paper where we introduced this supplementary complementary type of enhancement. Okay, then we realized that there is no data set available in the Indian context. Okay, because these whatever work till now I presented are on English data set. Like that ENLP 2017 paper was an English data set only, and that was on pure English. So we understood that there is no data set available in the Indian context. So we proposed the large scale multilingual multimodal summarization data set in the Indian context. So basically that in we pro- there, this date so we basically proposed a data set which is having 1.1 million instances, and there are 20 languages: English, Chinese, Spanish, Russian, French, Ukrainian, Portuguese, Japanese, Tamil, Marathi, Gujarati, Bengali, Sinhala, Urdu, Pashto, Indonesian, Telugu, Punjabi, Nepali, etc. So this is one of the largest multilingual summarization data set, and this is having 13 languages, and this is also the first ever multimodal cross-lingual summarization dataset having Japanese English. So we collected this dataset from the BBC site. So we explored the news domain and analyzed the structure of the articles. And after surveying the multiple news providers, we finalized the BBC News. So you can see in the BBC News there is a title, and there is a date, and there is some images, and then each image is also having a caption, and there is a summary written by the reporter only, and there is a text document. So my students have crawled this data set, and then they have written the human summary also. So finally our data set, each news article contains text document, images with corresponding captions, keywords, links to related news articles, and the multimodal summary. Okay, so this way we created this data set. We also created cross-lingual data set, contains all features from our final data set, along with multimodal summaries consisting of text in another language. And there are various languages, 20 languages. So for some languages there are more than 50,000 articles, for some languages there are less than 50,000 articles. So if the language is having more than 50,000 articles, then we are doing the split: 80% training, 10% testing, 10% validation. Otherwise we are having 90% training, 5% testing, 5% validation. So then we executed some for most of the Indian languages. There was no multimodal, multimodal classifier. But there was no multimodal summarization technique available. So we executed some unimodal summarization technique only, like randomly picking some sentences, lead threes, selecting the top three sentences. Text rank is forming a graph and then selecting some sentences. Centroid is also forming some clusters and then selecting some sentences. MT5 is a multilingual transformer, T5 transformer based approach. So these are some baseline results that we have provided on our newly constructed data set. And for English, there are some multimodal summarization models like MSMO. These are multimodal summarization models. So we propose these models on our data set, and then these are the results. So you know that this is our paper, large scale multilingual multimodal summarization data set. And please visit my site, because in my website this dataset is freely available. And if you want to work on multimodal Indian language summarization, then you can visit my website. So as I mentioned that nowadays we are working on a reader's comment aware multimodal summarization. Like what happens is that if the news reporter is writing a report, there are many readers comment nowadays. You know, suppose there is an online report and readers can interact with the reporter. So readers can post their comment on the news report. So we want to take the opinions into consideration, and that way it will be more interactive, and it will also overcome the personal bias. Like maybe the reporter is having his or her own personal bias, and we can also improve the engagement. Readers will also understand that they are more engaged with the report. So basically the task is that how can you incorporate the reader's comment into account in order to improve the summary quality. So there was a dataset available called the Reader Aware Multi-Document Summarization Dataset. So you can see RAMDS. So this dataset is having 45 news topic. There are 10 news document from different sources, and also there are corresponding comments, and there are human summaries. So for each topic, there are 4 random human writer summaries, and there is a dataset paper, and categories and the aspects are also there. And what are the categories? Accidents and natural disasters, attacks, criminal or terrorist, new technology, health and safety, endangered resources, investigations and trials, criminal, legal, other. So these are the different categories which are mentioned in the dataset. So you know that for each document, there are many comments. Like for example, here the reporter has mistakenly mentioned that this is a cruise ship. Like 57 people spend Christmas abroad, a cruise ship that has become stuck in the ice in a remote region of the coast of Antarctica, and rescue vessels are at least 2 days away. Australian Maritime officials told ABC News. Okay, so this is the original news. And then see the readers are giving their comment. Perhaps someone should inform Mr. Goldman on the difference between a cruise ship and an oceanographic research vessel. Having been on both these types of ships in my younger years, I found they have very little in common besides both being ocean going vessels. So basically, the reporter has mentioned this as a cruise ship, but the reader is saying that this is not a cruise ship, this is a oceanographic research vessel. So when the human writer has written the summary, human writer has considered this, and he or she has mentioned this a Russian research ship MV Academic Solasky with 74 scientists, tourists and crew abroad issued a satellite distress call after getting stuck in. So basically you can see that this way we can consider the reader's comment into account while generating the summary. So this RANDS dataset was having no image, but we want to work in the multimodal space. So what my student did is that he made this dataset multimodal. So he identified all the events mentioned in the dataset, and then he collected the images from the different sources corresponding to these events. So he manually identified referred news articles, and he collected multimodal supplementary data, and he manually annotated the images and added the images with the documents. Like for example, for each topic there is a minimum 2 images, maximum 69 images, median is 9. There are total 528 images. So, for example, this is a doc on the Australian wildfire. This is also a document on the Australian wildfire. And these are the few images that my student has collected regarding the Australian wildfire. And then he manually checked all the images, and then he added those images with the with the documents. So now this is the that the proposed model. So you can see now we are having three inputs: the articles, the corresponding comments, and also the images. So from the images we are extracting some features. Images are passed through ResNet, and then we are passing through PCA, principal component analysis. We are reducing the dimensionality, and then passing through LSTM. We are reducing the features. Articles we are extracting some key features. Comments also we are extracting some features, and we are generating some summary, and we are also having the that gold standard summary. And then there is a discriminator based training, like our model is generating a summary, so whether this summary is very similar to the original summary or not. So basically we are having a discriminator based training. So if the discriminator is able to differentiate between the goal summary and the generator summary, then there is a reward. This is our result. So you can see that rep sum is the textual based baseline where only text data is being used, and CSMS is our proposed model where we are using text plus the image data. So we can see that with the incorporation of the text plus the image data, there is a huge increase in the Russell score. So Russell is the longest subsequent match. So you can see that there is a huge increase in the Russell score. So initially, so we can see an improvement. So also visual modality. So there is a huge improvement in the F1 score also. Like we can see that image also we are able to extract good images for the visual modality. So these are some results. Like in the originally, this is our original summary: magnitude 5.1 earthquake followed by 115 aftershocks shook Los Angeles on Friday night. The epicenter was in Orange County, which is about 20 miles east of downtown Los Angeles. The boundary between two shifting lands on San Andreas fault mashed responsible for the earthquakes that displaced 83 residents. The earthquakes caused minor damages, including rock slides and water main break, but are no major injuries. The Red Cross opened a shelter in La Habra while the US Geological Survey is working on a device that is able to alert people to an earthquake 4 seconds before it is felt. Now the model output is a moderate earthquake that rattled a swathe of southern California, forced several dozen people in one community out of their homes after firefighters discovered foundation problems that made the buildings unsafe to enter. About 80 people were evacuated from their homes in the city of Farraton after the quake, which was followed by two smaller ones about 25 miles south of downtown Los Angeles. No injuries were reported. A rock slide in the Carbon Canyon area of nearby Brea also caused a minor injury. And so there are some hallucinations you can see. Like for example, original summary was mentioning 83 residents. It is mentioning 80 people. Then in the original summary, it was mentioning 20 miles east of downtown. It is showing 25 miles south of downtown. So there are some hallucinations, especially on the numbers. So these hallucinations are because the data set is very small. There are only 45 topics in the data set, and as the model is trained on only 45 topics, so there are hallucinations. And in the image you can see that two images are correctly identified, like this image and this image are correctly identified, but this image is extra, but this image is also showing some effect of earthquake only. So you know that so basically image precision is correct. So nowadays, what we are doing is that we are leveraging the benefit of LLMs, because large language models are trained on huge amount of corpus. So they are very good in generating text. So can't we leverage the pre-trained LLMs in generating the summary? So that's why what we are doing is that fast user comments are categorized into three categories. So complementary, supplementary, and relevant, and irrelevant, because all the user comments are not relevant. Sometimes users are simply commenting and they are giving arbitrary comments. So all the users comments are not relevant. So we are categorizing the readers comments into three categories: relevant, irrelevant, supplementary, and the complementary. And then we are sequentially we are padding the reader's comments with the document, and then we are producing the summary. So basically this is our proposed model, that opinion augmented classification and summarization framework. So you know that this is so we are first of all we are categorizing the comments into three categories: supplementary comments. So these comments further support or reinforce the information provided in the article. They may add examples or data that support the main points. Then complementary comments. These comments provide additional context on information that aligns positively with the content of the article. They offer insights that enhance the reader's understanding. And readers' comments which are not at all relevant with the document, okay? They are completely different, irrelevant. So, based on the content alignment, additional information, and the irrelevant perspective, we are categorizing the comments into these three categories. So, like for example, here you can see that this is a monarch butterflies draw. So this is the original document in 2013. Data collected by the WWF, Telcel Alliance, and Mexico's National Commission for Protected Areas revealed that the number of monarch butterflies hibernating in Mexico reached an unprecedented low. Surveys conducted in the forested areas used by the hibernating monarchs indicated that only 1.65 acres were inhabited by them in December 2013, marking a 44% decline from the same period the previous year. Several factors have contributed to the sharp decline in monarch populations in recent years, including changes in land use leading to the loss of reproductive habitat and a decrease in milkweed, the primary food source of our monarch larvae, due to herbicide use. Additionally, extreme climate conditions in Canada and United States and Mexico, along with deforestation and degradation of hibernation sites in Mexico, have played a role in this decline. If this is the original document, now you see the complementary comments. A major decrease of many bird species, the continual decline of the 20,000 species of bees, a troubling decline of many other pollinating and necessary insects, bats dying off, and the fact that human cancer death rates are low are now an epidemic. The idea that they live on just milkweed is misleading, as they do use other food sources. But the fact is that monarchs use milkweed for a specific purpose. It is a poisonous plant, and they use that to poison their bodies against predators, mostly birds. But as milkweed becomes scarcer, the birds have learned that not all monarchs carry that bitter taste to protect them. So these here there are some information which are not present in the original document. So that's why these comments are categorized as the complementary comments. But if you see this comment, plant more milkweed in prairies, it's a weed, it should flourish. Insects you see just as migratory birds need their symbiotic plants, which are always native plants, as the relationship developed over centuries to thousands of years. So here these are containing the same information which are present in the document. So these are supplementary. And the third category, people need to remember we are at the top of the pyramid. So what happens beneath us affects us. So this is not at all related to the document. So these are the detached comment. So this way we are categorizing the comments into three categories. Now this is the proposed architecture. So there is a classifier. So we can utilize any transformer for the classification purpose, or we can also use any LLM for classification purpose, or maybe we can also utilize cosine similarity with the original document for the classification purpose. So basically we are asking a classifier to classify the comments into three categories: supplementary, complementary, and detached. After that, each type of comments are sequentially added with the news document, and then we are passing them through some LLMs. So LLMs could be GPT 3.5 or the Bloom or the Plan T5. So we are passing the document and also the comments sequentially to the LLM, and then we are asking the LLM to generate the summary. So this is the final summary. So this is a two-stage approach. In the first stage, we are categorizing the comments in three categories: supplementary, complementary, and the detached. And then each category is added with the document, and then we are asking the LLM to generate the summary. So these are some results. So we have varied the LLM. Like here, these are the results with GPT 3.5. So you can see we are measuring the Ruse 1 score, Rusell score, BART score is basically semantically similar. Like whether your goal summary and your generated summary are semantically similar or not. Then BART score is also giving us a probability. So whether your generated summary and the like and the this is also a semantic similarity, and the reading and readability score, whether your generated summary is readable or not. So these are the different types of scores that we have produced. Then Flan T5, this is another LLM that we have used, and also Bloom. So these are the some of the tools and techniques that we proposed in summarization. Okay. So now let me discuss another application of multimodal information processing, which is in complaint mining. So complaint mining is another important task. So complaining is a speech act used to express a negative mismatch between reality and expectations. So suppose there is a we have purchased some product online. So any question up to this summarization problem? Any question up to the summarization task? In the chat box, is there any question? Anyone having any question related to the summarization? Okay, so then let me continue with the complaint mining task. So this is the complaint mining task that sometimes whenever we are purchasing products online, we are writing our reviews in the online forum, okay? And these reviews contain complaint. Like for example, I love boots. Shame you are introducing a man tax of 7% in 2018. So this is a complaint, and here you can see the sentiment is also negative. So we need to identify whether a particular review contains complaint or not. So automatic classification of complaint text in natural language is of extreme significance for linguists to acquire a better grasp of the specific context or purpose. So, you know that mostly whenever we are writing complaints in the online platform, these complaints are also multimodal. Like we are not only writing the textual reviews, but also we are uploading the images of the products, the defected product. Like for example, you can see that Amazon delivered expired product, fungus infested, hate such service, it's unbelievable. Product not worth it, throwing into dustbin. We have also uploaded the image. So given this image plus text, we are categorizing whether this is complaint or non-complaint, and also what is the emotion of the what is the emotion of the person and what is the sentiment of the person. Like sentiment should always be like when the person is complaining, on the day sentiment should always be negative, and emotion should always be sad or the anger or the disgust. So there is a correlation between the complaint with the sentiment and emotion. So if the person is complaining, then the sentiment should be always negative, and the emotion should be always anger or the disgust or the sad. So basically, when we started doing research in this particular area, we did not find any particular paper, particular work, particular data set available for the multimodal space. So we created our own data set for the multimodal complaint mining. So we crawled the data from the Amazon India's website. So this data set is called the complaint emotion sentiment annotated multimodal Amazon reviews data set. And this data set is having 3962 reviews, and it is having 2641 non-complaint categories and 1321 complaint categories reviews. So basically, so basically these are some examples from the data set. Like received the book and started reading it. After a few weeks, many pages of the book are blank. and not readable due to poor printing quality, disappointed. So here you can see the domain is books, labels are complaint, sentiment is negative, and emotion is sadness. Food damaged by paste not acceptable. Kindly avoid purchasing online items where food is concerned. Yuck. So the domain is edibles, labels are complaint, sentiment is negative, emotion is disgust. All in all, this product was satisfying and I am happy with my purchase from Urbano. Product looks new and nice and comfortable too. So fashion is fashion, domain is fashion, labels are non-complaint, sentiment is positive, emotion is joy. So then we proposed a multitask based approach. So we are extracting some features from the images. So we are extracting some features from the sentence, and then we are passing through some dense layers. And then that we are having labels like complaint labels, emotion and sentiment levels. So our main classification task is the complaint identification, and emotion and sentiment are our auxiliary task. Okay, so we are having some error in the emotion task and also some error in the sentiment task. But our main focus is on the complaint because emotion prediction and the sentiment prediction are our auxiliary task. So these are some results. So you can see that we are multitask results. So basically we are able to, we have shown results with only text and text plus image. With only text, we are getting only 84.22% accuracy, but with image, with the addition of image, there is a 1% improvement in the accuracy. So that means that we are able to extract some useful features from the images. Similarly, you know that there are some, we have also added some multitasking is also helpful. Like when we are having only single task, we are getting around 80, 83% accuracy, but multitasking is giving 85% accuracy. So we also did some error analysis. Manually we checked the errors. So what are the main reasons of errors? So main reasons of errors are as follows. Like one is this ironical instances. So like if the person is writing sarcastically, the comments, like if the person is writing sarcastically the reviews, like if the reviews contain some ironical comments or the sarcastic comments like biscuits with oil might be a rare combination of Amazon nowadays. Instances having irony or comments where the underlying tone is positive or neutral, but the instance is a complaint type, then the model will not be able to understand this. The sarcasm, the model will not be able to understand. Then multifold sentences, if the sentence is very long and although it's not a Microsoft genuine product, it's good quality and comfortable to use. Price is really reasonable too when compared to its build quality and features. So it's a very complicated sentence. Then also the model will not be able to understand this. And then also there are more number of there are very less number of complaint categories. Only 33% samples are of complaint categories, and 67% samples are non-complaint categories. So that is also a problem. So there is a biasness towards the non-complaint category. So next what we did is that we dig inside, we go into more deeper level. So till now we are only detecting whether a particular review contains complaint or non-complaint. But now we are more interested in identifying on which aspect the person is complaining. Like a product can have many aspects. A mobile phone has many aspects like camera quality, battery life, that color or the size, etc. So on which aspect the person is complaining. Like if the person is saying the packaging of the product is great, but the taste is pathetic. So here on the packaging aspect, the person is having no complaint, but on the taste aspect, the person is complaining. So on which aspect the person is complaining. So we are identifying the aspects and then on which aspect the person is complaining. So we proposed a multimodal complaint data set. We extracted the aspects from this data set, and also for each aspect we are detecting whether there is a complaint or non-complaint. And then we proposed a two-stage framework. So in the first stage, we are extracting the aspects, and in the second stage, we are extracting whether there will be a complaint or there will be a non-complaint. So you know that we extended the previous dataset only now in the aspect level. So there are four domains: books, edibles, electronics, and the fashion. For the books domain, the aspects are content, packaging, price, and the quality. For the edibles, there are 450 instances. The aspects are taste, smell, packaging, price, quality. For the electronics, instances are 1507, where aspects are design, software, hardware, packaging, price, quality. For the fashion, the instances are 1275. Aspects are color, style, fit, packaging, price, quality. So these are the some instances like taste of rental was very good but received torn package. Here the aspect categories are taste and the packaging. For taste it is non-complaint, but for the packaging it is complaint. Ordered blue color but received red color t-shirt. Here the aspect category is color and the label is complaint. Received defective piece, now not able to give the replacement also. So here there are two aspect, quality and the service, and on both aspect the person is complaining. So we are having two-stage approach. So basically we are there is a review image and then there is a review text. A cheap quality order, black color, receive different shots, good packaging, and then also given the image you are extracting the web entities, clothing, outerwear, shorts, and purple. And so given the review text and the web entities, we are passing through the text encoder and also the image encoder. And so given that text encoding and the image encoding, there is a multimodal transformer. So this multimodal transformer are extracting the aspect categories. Like you know, the aspect categories are this that quality, color, and the packaging. And then for each aspect category, we are detecting whether for each aspect there is a complaint or non-complaint. For quality, there is a complaint. For color, there is a complaint. For packaging, there is a non-complaint. So these are the results. So that you can see for books, what is the accuracy or the for aspect category detection and aspect complaint classification. We have provided results for each domain: books, edibles, electronics, and the fashion. So next we dig inside and we are identifying not only the aspects and the complaints, but also for each complaint type, what are the reasons behind the complaint, like which phrases of the text are responsible for saying that there is a complaint. So for example, if we are saying that taste of rental was good but received torn package, so receive torn package, this phrase is responsible for saying that this is a complaint. So like you know, here there are two aspect categories: taste and the package. And for taste there is a non-complaint, and for package there is a complaint. And the corresponding phrase is receive torn package. So this receive torn package also we are highlighting, we are extracting as a part of the output. So this is the aspect-based framework for the complaint detection. So we are not only finding out the aspect categories, but also the labels and also the why part. So what is the reason? What is the receipt torn package? That part also we have to extract. So we annotated the dataset. We enhanced the previous dataset only, SESMA dataset. Now we are like we have to solve three tasks: aspect category detection, aspect label complaint classification, and aspect label rational detection. So like you see that product quality is quite good but did not like the fit, tight on shoulders and this image. So here there are two aspect categories: quality and fit. Quality is non-complaint, fit is complaint. For quality, as this is non-complaint, there is no span. And for fit, the reason is tight on shoulders. Package torn near GPR, slippage noticed, complaint got no response, pathetic service. Here there are two aspects: package and service, both are complaint. and the spans are torn near zipper, got no response. So this is a proposed approach. So we are having a generative approach, sequence modeling. So we are also adding the common sense knowledge. So you know that common sense, the review is passed through the common sense knowledge and concept net, and this then it is added with the visual our encoder also, and then we are passing through the sequence model, and the sequence model is generating the output like the what is the aspect category, complaint non-complaint level, and also the reason. Okay, so what is the reason, like cheap quality material, wrong color, or the good packaging. So these are the reasons. So we are also identifying the phrases which are responsible for detecting the complaint. So this is a sequence model. So these are the results you can see. We for each domain we have provided the results with comparison with several baselines for both aspect category detection, aspect complaint classification, and aspect rational detection. So these are some current research on that we are currently doing on the cyberbully or not. Then medical question summarization, I mentioned that often people are posting their medical concerns in the medical forums, and these medical questions also contain the code mix content. So can we generate a summary out of that? Then poem narration. So given a poem, it is very difficult to understand the poem meaning, because poems are very difficult to understand sometimes. Can you generate some images corresponding to the poem so that the children can easily understand the meaning of the poem? Then you know there are many financial experts who are providing their expertise through financial videos, but these videos are very long. So can we generate a summary of the financial videos? Then we are taking many drugs and we are suffering from many side effects. We are writing about the side effects in the social media. So can we generate a summary of the side effects? Then I mentioned about the fake news, that in the Indian context there was no data set available. So we generated some data sets in the fake news in the Indian context. So yeah, these are some of the research areas that currently we are doing. So there was a question. Yeah, Rakesh. Rakesh, go ahead. Rakesh, you have a question? Rakesh, you raised a hand. Yeah, these are some of my publications, and you can visit my webpage, and you will get all the publication details in my webpage there. And then thank you in a multilingual way. Yeah, so I think I can take some questions now.
Participants, if you have any query, please ask. Any queries? Thank you so much, ma'am, for delivering such as insightful and engaging session. We truly appreciate the time and effort you took to deliver this lecture, and I am sure our participants has gained a lot from your session. It has been a privilege to have you with us today. Once again, thank you, ma'am, for your contribution, and we look forward for future opportunities to learn from you, ma'am. Thank you so much, ma'am.
Thank you. Thanks a lot. Thanks a lot. Thanks a lot, Dr. Sweta, for inviting me.
Ma'am, I want to say one thing.
Yeah, Abdul. Yeah.
Yes, ma'am. Actually, how we can apply multimodal methods in the field of computer vision? Kindly uh, explain in brief so that we can get it.
Yeah, so basically, as I mentioned, no, you have to extract some features from the text and also some features from the images, and then you need to fuse them. Like you can fuse using attentions. So, like there are many attention mechanisms, intermodal attentions. So you can fuse them through attention, and then you can pass through some classification layers.
Okay.
So you can do early fusion or the late fusion or yeah, these are the two mechanism, early fusion or the late fusion. So mostly this is a standard approach. You extract some features, like you pass the images through some CNNs, you get some feature vector, you pass the images text through some transformers, get some feature vectors, and then put some attentions, and then you fuse them together and then pass through some classifiers.
Okay, ma'am. Thank you so much. Thank you, ma'am. I got it.
Any more queries? Thank you so much, ma'am, for your valuable time.
Yeah, thank you so much. Yeah. So then I can leave now, na?
Yes, ma'am.
Thank you, thank you.
Thank you, ma'am.
Bye bye.
Bye, ma'am. Now, participants, you can leave the session. The next session is from 2 p.m. So, again, you will join the session.